Hello everyone, myself Pushkar Toj. Currently, I am a final year student of the Department of Physics and Photonic Science at NIT Hamirpur. And here gonna present you the presentation on the topic of microwave oven. And I am really thankful for the Mercy to providing me this great opportunity on this. Firstly, we're gonna see about our introduction part. So here we're just gonna see about the table of the contents what we're gonna discuss. First we have the introduction to the C programming, then we have the introduction to the embedded systems, then we get to know about the what is a microwave oven, and then we're gonna tell you about the different requirements of the projects which we gonna require for implementation for implementing this project, and then at the end we're gonna implement this project. So we're gonna discuss all these things one by one. So first we have the introduction to the C programming. So this is basically the structure of the C programming, where it have the header files where we include the main studio.h, and we have the main part where we just get the value and that integer main. Then we have the variable declaration, where we can declare different variable values that can be a int value, a char value, double value, float value, unsigned character, anything which we're gonna discuss later in the slides. Then we have the main body part, where we can print our function whatever for for printing the function we have that printf percentage d dot, and there a is the that particular variable, and in the end we have the return 0 dot comma. So now we're gonna discuss about the different data types in the C programming. So we have the main three types of data types. The first one is the primitive type, the second one is the derived type, the third one is the user defined type. So the primitive types has a character, it can has character values, integer values, float values, and double values, and voids. The derived types can have the signed, unsigned, and long double. So it can be signed and have the signed character, signed short type, signed int type, and signed long type. Unsigned can have unsigned character, unsigned short, unsigned int, and unsigned long. And the third one has the long double. Then we have the user defined type, where we have the array, and that have a structured union and in-one type. So now we're going to look at the different statements in the C programming. So first we're going to look at the different conditional statements in the C programming. So majorly it has two conditional statements. The first one is if-else statement, and the other one is the switch case. So in the if-else statement we have the if case, then we have if-else case, then we have if-else if case, and then we have the nested if. So in the if case we just only have an if condition. If it is true, it just execute, and if it's not, it just came out of that. If else we have the if else condition. Here, if the condition is true, then it just execute if part, and if the condition is false, it just execute the else other part of else. Then we have the else if statement, else if statement. So here, if we have the condition one is true, then else if we have the condition to true, and else then we whatever way condition is true, it's gonna execute here. Then we have the nested if. Here it is just similar to the if statements, but here we just conclude all the other if statements in the if statements. Then we have the switch case, where we have the switch expression. So here we have the different cases. And the case number one just break the statements, and we have the case number two, which can just break the statement. We have the case number three, just break the statement and run the default case, whichever we have. Then we're gonna see at the different loops in the C programming. Majorly there are two loops in the C programming. The first one is the for loop, and the other one is the while loop. So in the for loop, we just first initialize the value, then check the condition, then execute the particular body, then update the variables, repeat, and then exit the program. In the while loop, we have first the checking condition. If it is true, then we just execute the body gets executed and updates the variable and repeat, and then exit. Then we also have the third case, which we have the do while loop. So here it just first executes body, then checks the condition. If it is true, then it repeats and exits. Now we're gonna discuss about the different pointers in the C programming. So basically a pointer holds the variable, holds the address of a data object or a function. A pointer can be referred to an object of any one data type. It can't refer to a bit field or a reference. Some common uses for pointers are to access dynamic data structures such as linked lists, trees, and cubes. So here, we have the things about the C programming. Now we're gonna discuss about the embedded systems, a basic introduction to embedded systems. So what embedded system actually is? So an embedded system is an integrated system that is formed as a combination of computer hardware and its software hardware for a specific function. So basically ये हार्डवेयर और सॉफ्टवेयर का कॉम्बिनेशन होता है जिसको बना के जो हमें किसी भी पर्टिकुलर स्पेसिफिक टास्क को परफॉर्म करने के लिए इसको हम बनाते हैं. So it can be set as a declared computer system has been developed for some particular reasons, but it is not a traditional computer system or general purpose computers. There are the embedded systems that may work independently or attached to a longer on a few to work on a few specific functions. These embedded systems can work without human inventions with little human inventions. So then we're gonna look at some of the basic example of the embedded system. So it has the fire alarms, the microwave ovens, washing machines, televisions, laser printer, all of things which you do for a specific task are considered to be as the embedded systems. Now we're gonna look at the block diagram of the embedded system. So here we have the microcontroller, in which we have the microprocessor inbuilt, the RAM and the ROM. Here we have the buses, the different buses of address type, the data type, the control type. There we have the different ports, the input port and the output port. Then we have the external circuits and a physical device which is connected to it. Then we have the different signals. Basically, this one is the input signal and the output signal coming going into the physical device. Now we're gonna discuss about the difference between the basically what a microcontroller and microprocessor is. So a microcontroller can be understood as the heart of the embedded system. A microcontroller is a controlling device wherein the memory and the I/O input components are present internally. These are present on the chip memory. And a microprocessor can be understood as the heart of the computer system. A microprocessor is a processor where the memory and the I/O are connected externally. The circuit is complex due to external connections. So basically microcontroller is referred वो हार्ट ऑफ एम्बेडेड सिस्टम है, लेकिन माइक्रोप्रोसेसर जो है वो हार्ट ऑफ पूरे कंप्यूटर प्रोग्राम का हार्ट है. जैसे हमने पिछले स्लाइड में देखा कि एक माइक्रो कंट्रोलर के अंदर एक माइक्रो प्रोसेसर इंटरनली जो है बिल्ट इन करता है. So as you can see the microcontroller is components are present internally, whereas a microprocessor components are connected externally. So here we have the microwave oven. So this is the particular our project aim on which we're gonna work. That is the microwave oven. So firstly we're gonna know about what a oven is and what it does, what it is for. So microwave oven is a relatively small box-like oven that raises the temperature of food by subjecting it to a high frequency electromagnetic radiations. The microwaves are absorbed by water, fats, sugars, and certain other molecules whose consequent vibrations produces heat. सो और दी मॉलिक्यूल्स की जो बेसिकली वाइब्रेशनल एनर्जी होती है जिसकी वजह से वो मूव करते हैं, उसकी वजह से उसके बीच में जो है वो हीट प्रोड्यूस होती है. तो बेसिक कंपोनेंट माइक्रोवेव ओवन का ये है कि हमारे फूड को वो गर्म करता है. Then we're gonna look at the different modes of the microwave oven. So here basically we have the main 4 modes on which that microwave oven works. The first one is the micro mode. Basically this mode is used to cook food in a traditional way. So it uses a maximum power of 900 watt. Then we have the grill mode. So this mode is used to cook meat and bread. A user can set time as per the cooking time of the meat. Then we have the third mode, the convection mode. In this mode, user can set the oven to preheat for a particular temperature and it takes 3 minutes to preheat the oven. So basically यूज़र यहाँ पे इनिशियली कोई भी पर्टिकुलर टेम्परेचर सेट करता है तो वो पर्टिकुलर ओवन जो उस टाइम के लिए एक इनिशियल थोड़ा सा टाइम देता है उस टेम्परेचर तक पहुँचने के लिए, तो वो टाइम पर्टिकुलर टेम्परेचर तक पहुँचने के लिए वो टाइम देता है और इट कैन टेक एनी टाइम टू preheat the oven. Then we have the start mode. This mode default time is set to be 30 seconds. So then we can interrupt the time to set the required time. तो जैसे ये टाइम बेसिकली कंप्लीट हो जाएगा तो एक हमें बीप की साउंड सुनाई देती है that our food is ready or our food is cooked. Now we're gonna discuss about the different requirements in the embedded system. So what components you gonna know if you are if you are working on this project. So first you have to know about the knowledge in the embedded C, about the embedded C programming and what an embedded system is. Down here have the three different peripherals on which we're gonna work. So first one we have the MP. So here we gonna write all our codes, and then we have the X8 compiler. As you all aware about what a compiler do, just executes our code and finds out if there is an error or not. And third one is the PixSim Lab. So PixSim Lab simulator. So it is basically a simulator on which our code gonna give us the output. All of the executed, we just gonna see the output on this PixSim Lab simulator. So here we have one more important component where we are using in this, that is the PIC16F877A microcontroller. So this is basically the microcontroller which we are using here. And now that PIC Simulator Lab also have these peripherals. The first one is a 616 into 4 CLC screen. So it also has a 16 into 2 CLC screen. Then it has tactile switches, the matrix keypads, and the timers. We're gonna discuss all about things one by one later in these slides. So first we're gonna discuss about different peripherals to be used in this project. So first we have the MPLAB XID. So we have used MPLAB XID for the writing the code of our project. So the code is basically written in this C language. Then we have the X8 compiler. We have used the X8 compiler to compile our code to get about the errors. Then we have the PIC Simulator Lab. We are simulating our project using PIC Simulator Lab Simulator. So here we're going to see our output of the projects. And there we have the microcontroller which we are using here, that is the PIC16F877A. Now we're going to see at the microcontroller which we are using here, that is PIC16F877A microcontroller. So basically this microcontroller has 5 ports. So the names of these ports are the port A, port B, port C, port D, and port E. And these all ports are bidirectional, and these ports contains the pins which are total of 40 pins. Port A basically consists 6 pins, port B basically consists 8 pins, and port C also consists 8 pins. The fourth port also consists the 8 pins, and the last port contains the 3 pins. So basically it contains all over 40 pins. And the size of this PIC16F877A microcontroller is the size of the data bus, which is the 8-bit. So here also here you see that we have the 40 pins all over here. Just more little bit of it. So here you can see that we have the 40 pins all over here. Now we have the different peripherals which are on the PIC16 Lab Simulator. The first one here we have the CLC screen. So what CLCD stands for? It stands for Character Liquid Crystal Display. So in PIC16 Simulator Lab, there are two types of body displays. The first one is the 16:2 display, and the other one is the 16:4 display. So here we are using this 16:4 display. So it displays the ASII characters and some specific characters. Two types of communication modes, and basically the first one is the 4-bit mode, the other one is the 8-bit mode. Now we're gonna see at the toggle switches what a toggle switch is. So a toggle switch is one type of widely used switch that completes an electrical circuit typically when pressure is applied to the user by the user, which then gives the user a perceptible click or a haptic bump indicating the current flows. So basically tactile switch में basically हमारे पास एक component होता है, एक switch लगा होता है जिसको हम जब प्रेस करते हैं तो एक इलेक्ट्रिकल सर्किट जो है कंप्लीट हो जाता है, जिसकी वजह से करंट कर देता है ना शुरू कर देता है, और जैसे हम उस कंपोनेंट को छोड़ते हैं स्विच को, वो करंट फ्लो ब्रेकेज हो जाती है. सो द करंट फ्लो इज टर्न्ड ऑफ व्हेन दिस. So what is the use? So what is the use of this in our projects? So in our project we had used toggle switches for entering time, temperature, or to take the mode of operation from the user. So here we are using this switch to enter the time, temperature, and different modes of operation inputs from the user. Then we will now see about the matrix keypad. What a matrix keypad is? A matrix keypad is a kind of keypad you can see on microwave ovens, gas pumps, and calculators. A matrix keypad you can connect to a breadboard is also great for prototypes and inventions where things like codes, times, and other values have to be entered. This is used when more number of user inputs are required and still want to save some controller IO's input. Now see about different interrupts. An interrupt is a request from the processor to interrupt currently executing code when permitted, so that the event can be proceeded in a timely manner. If the request is accepted, the processor will suspend its current activities and save its states and execute a function called an interrupt handler or an interrupt service routine (ISR) to deal with the event. This interruption is often temporary and allowing the software to resume normal activities after the interrupt handler finishes, although the interrupt could instead indicate a fatal error. Then we're going to discuss about the ICR. What ICR stands for? It is basically an interrupt service routine. An interrupt service routine is that routine that hardware invokes in response to an interrupt. ICR examines an interrupt and determines how to handle it, executes the handling, and then returning a logical interrupt values. If no further handling is required, the ICR notifies the kernel with a return value. A basic example of ICR is a routine that handles keyboard events such as pressing or releasing a key. Each time a key is pressed, the ICR processes the input. For example, if you press and hold the right arrow key in the text file, the ICR will signal to the CPU that the right arrow key is depressed. The CPU sends this information to the active word processor or text editing program, which will move the cursor to the right. When you let go of the key, the ICR handles the key up events. This interrupts the previous key down state, which signals to program to stop moving the cursor. Now we're gonna see at the different timers. So basically, timers is an important application in any embedded system, which is a default peripheral. They are used to keep a record of time for different events occurring in the embedded systems. The timer is a simple binary counter which is configured in a circuit or a system as per the need to count the pulses in the system. The value of the timer is automatically set to 0 once it is at its maximum value. So here you can see the timer block diagram. So here we have the source signal, then we have the prescaler, and here we have the timer register which is of 8 bit or 16 bits, and then we have the post scaler. Now we're going to look at the project implementation, how all these peripherals are used to implement our projects. So wait a minute for I'm just opening the PicSimLab simulator here. So here I have the PicSimLab simulator. So I just so here you can see we have the different matrix keypads. That's the different keys at 1, 2, 3 which are numbered years, and here we have the different LEDs, and here we have this micro grill convection. Here we have the CLST screen. It can change to be 16 into 2 peripheral, and this is this 16 into 2, and this one is a 16 into 4 screen. So now I just wanna reset, and this is the reset button here. So I'm really sorry, I'm just gonna open it again. Just wanna open the port which we're gonna require it here. That is the PicGenius port. So here we have that PicGenius port, and here you can see we have just powering on the microwave oven. So, and here you can see that we have the different modes, the micro mode, the grill mode, the convection mode, and the start mode. I just turn all the LEDs off. Oh, wait a minute for a second. I'm just keeping all these LEDs off, and these are the different peripherals over here. So basically we have the reset button over here. So as I just reset it, we just shown the powering on microwave oven, and after a wait we have just shown the different modes. The first one is the micro mode, the second one is the grill mode, and the third one is the convection mode, and the fourth one is the start mode. Then I'm just gonna click on the first one mode, which one is the uh, micro mode. It just got stuck, I don't know. So here you can see we have the different modes. The first one is the micro mode. I just click, it shows the power of 900. So here we just gonna enter the time over here. So here from the hash we just enter the time of a row second, and then it just showing the cooking time and it just start beeping over from the buzzer. We want to listen about the sound over here, and this is the peripheral over here. Now we're going to see at the second mode, which is the grill mode. So here you can see we have this to set the time. So you're going to set the time of cooking the food. So I just put it the 6-second time, and it just again started, and when the time completes just starts buzzing again, and here we can show cooking time up. So here it is the grill mode. We're gonna see at the third mode which one is the convection mode. So here we have to set the uh, temperature over here. So the user just setting the temperature. So here I just invented temperature over here. So I just have to set the temperature of a value which I have put in my code. you just setting the temperature. It just take this time of preheating to that particular temperature. It just takes a time of preheating a little uh, of time of just here it just shows 50 seconds time of preheating to that particular temperature which is set by the user. So whenever you just put your food there, you just got that particular preheat temperature which you have set by the user. So just wait for more 25 seconds. We have the time remaining at 20 seconds. 10 seconds remaining over here. So just we have 7, 6, 5, 4, 3, 2, 1, and they just get to that particular temperature. Now you can just uh, set the time to heat up the uh, to a particular time for heating the food. So here is basically the reset button, and I'm just gonna click and it just shows to this initial point where we're just starting powering on microwave oven, and it's showing the different modes. Now I'm gonna see about the fourth mode, which one is the start mode, and I'm just clicking on the fourth peripheral. Here I just initially set the time of 30 seconds. So here we have the different components: just start, resume key, then the fourth one, the pause key, and the stop key. So after that particular 30 seconds, it's just giving me a cooking up beep sound from the buzzer, where we have the buzzer, and where here we also have the cooler over here. So its time is completing. It's 3, 2, 1, and so on. And here we got the cooking timer, and we just got it out from the buzzer of a beep sound, and here it just gone from the initial way.